Assalamualaikum and hi to all. So I hope that you are in a good condition, in a safe place. And in this video, I'm going to cover 6.4, which is virtual memory. So previously, we already go through on 6.2 main memory and also cache memory. And in cache memory, there's a lot of scheme that you need to remember, and some part of cache memory before end of our cache memory you already were given with, where is it, okay, uh, another subtopic which is under effective access time. And in our class I already mentioned to you that you need to remember, you need to memorize this equation. So if let's say for your final exam there is no equation will be provided, so if you are given with equation, just ask the example over here, you need to come up with your own equation, and then after that you need to solve it. Maybe you need to just give the answer like 11 nanosecond and so on. So throughout your working step, so if let's say for e-learning, I don't think that it's will ask you to show your working step, but the important thing is your answer. So last time I did ask you to try all the example, and if you look here you have also exercise, and there is several other like review question, and please try to do all the it for all the it question. So it's very important, because if you look that in 6.3 you're going to see it question, and for your 6.4 also, after this you're going to see there is a few example also that cover and ask you to calculate the e. So now I guess in this video it's very short, because only like not more than 10 pages. So let's take a look what we have in our virtual memory. So this one is basically on more on theory reading things.
It's 0 hours.
Okay, sorry. More on theory reading things, and if you like reading and you want to know more, you can always refer to the reference stated here. Okay, so you can see that throughout our module 6, we already cover and we look onto cache. Module 5, it is totally different, that we are looking into the control unit. Now under module 6 we did see everything about cache, and this is like the recap back, the overview on the cache and what we already learned, and some part is the correlation between some things new with the cache. So now we know that cachings allow a computer to access frequently used data from smaller but faster cache memory. So cache is found near top of our memory hierarchy. This one you already look the pyramid things. So you remember back how about the flow of this pyramid. Of course the cache is on top of the pyramids of memory hierarchy, and yeah, throughout it's getting bigger and getting slower and less expensive. So maybe you can try recap back and look into your previous 6.1 slide, and you're going to find out the pyramid. So another important concept inherent in hierarchy is virtual memory. So now you have another part, which is virtual memory. The purpose of virtual memory is to use the hard disk as an extension of RAM. So now you look back that you have another word which is frequently used previously, which is RAM, thus increasing the ability address space of process can use. So please try to understand it. And this is the new term, maybe a new term for you. The most common way implements virtual memory is by using paging. So main memory is divided into fixed size block. So every blocks in your memory already fixed size blocks, and program are divided into same size block. So your will like divided it into several block. I just show you example, but the size of every blocks is similar. So it's either why depend on your scheme, either the size is perpendicular or in another way, verticals, or maybe it's looks like this. So the size of your blocks, all the size is equal or same size block. Typically, shrunk of the program are brought into memory as needed. It is not necessary to store contiguous chunks of the program in contiguous chunks of your main memory. Every virtual address for a program that generated by CPU must be translated into a physical address. So if you want to send it into the if let's say you want to use a virtual address for your program, you need to generate it by CPU first and translate into a physical address. So here there is a lot of sentences. Maybe it's quite boring when you hear this, because you can just read it by yourself. So here is the examples, some frequent used term. So normally you will like see this kind of wording, this kind of term, and some part of it is very important. Maybe it's going to be asked in your final year final question finally yeah final final exam. For your final exam, it's going to be like us. Let's say I give you an example, maybe okay, let's pick the correct descriptions about virtual address. So maybe you were given 4 from A, B, C, D, and let's say this is A, B, C, and D. So you need to pick the correct answer. So it might be come out also like that. And you can see that you have from module 1, 2, 3, 4, 5 until 8. So many questions can be asked in your objective, in your subjective question. So you can see now you have a lot of definitions. So which one that might come out? So that's why you need to memorize and understand. I think so. If you memorize, it's very hard, because but I think different kind of person have different kind of ability. So like me, it's very hard for me to like remember all of this, because this is one table only. So we have a lot of table, a lot of definition, a lot of functions. Every term have a function, have the description. So if I need to remember one by one, it's very hard. So the best way for me is like to understand what is the virtual address. So I just find the keyword when I understand, so it's easy for me just to pick it the correct answer. if let's say it is MCQ questions, or in a in a subjective questions, I can just try to rephrase by my own words, isn't it? So next, okay, this is table for some frequent use term for virtual memory implemented through paging. So first is a virtual address. So you can just read through the description. There is a physical address mapping, page frames, pagings, fragmentations, page faults. So I really suggest a good words, suggest to you to memorize all this term. Okay. Next is, okay, virtual memory can be implemented with different technique. So you have 3 technique that you need to remember. First is paging, second is segmentations, and another one is a combination between 2 techniques over here. So you just need to remember that there are 3 different techniques for your virtual memory to be implemented, which is paging, segmentations, and the combinations between these 2. So it's not too hard, right? Just to remember. So maybe is it come out to MCQ or not? We did discuss among us, which is lecturer. We did discuss. It is like quite hard, okay, for student to figure out what question that will be come out, because a lot of subtopic, a lot of I think there are definitions and many things that you need to cover for your final exam. So maybe you can try to have a look into your past year questions and try to spot between among you what type of question might come out. So you focus to certain topic only, because I don't think that's all of the topic will come out, of course, because we have like of number of question can be asked in our final exam. So among of these 3 techniques, the most popular techniques is paging. Okay, here is the flow by putting it all together, which is the TLB, page table, cache, and main memory. So I don't think that is going to be like asking you to memorize all these detail inside. It's very hard for you to remember and memorize. So maybe you can just go through and understand the flow. Okay, here is the example for it again. So if you can see, the most important thing that you were given with all necessary point, necessary keyword, what is the keywords that you need to see. So all the keyword, all the detail already given in the question, you just need to implement it into the equation. So please go back to your 6.3 under our EAT, and then please memorize the equation, and you can answer it easily. So there is a few questions for the example. Please try to do it. It is not very hard. It is just for you to like implement it into the equations. So now I guess it's nearly to end, but before that, you can see we have another informations related to a real world example. So you have a lot of processes in the world, but one of that is Pentium. The Pentium architecture exhibits fairly characteristic traits of modern memory management. So you can see over here you have the example of 32-bit virtual address and 32-bit physical addresses, which is used either 4K or 4 mega page size. When used paging in different combinations of paging and segmentations. So you can go through it all about your cache. There is two cache, which is L1 and L2, both utilizing a 32-byte block size. And then you have another detail about your cache, which has the translation look aside buffer. And how about the size also is already given. So this is example on our Pentium. So you can see how the Pentium memory architecture hierarchy look like. So let's say over here you have a computer, and this is your Pentium memories, and you have the CPU, you have a cache that connected to your CPU L1, and then you have the TLB also inside your L1 cache, and so on. So you have another one like L2, and then main memory and virtual memory. This is like parametry also, if you still remember, but this is how it's connected to each other. And among of that, you can try to summarize it that computer memory is organized in hierarchy, which the smallest faster memory at the top and largest slowest memory at the bottom. So this is about our pyramid things on the hierarchy. Cache memory gives faster access to main memory, while virtual memory uses this storage to give the illusions of having large main memory. Cache map blocks of main memory to blocks of cache memory. So you can go through and read all the summarizations about our module 6. I think about the FIFO and so on is also important for you to remember. Yeah, if not mistaken. So I guess only that for our video this time, which is only cover 6.4 subtopic. Later on we will jump to another module, which is module 7, and I'm going to speed up a little bit. And yeah, see you soon. Bye bye.